Welcome to the debate. Usually when we talk about software automation, there's this persistent fantasy of the single button. You define a problem, you push a key, you lean back, and you calmly drink your coffee while the machine just does the work.
Right, the ultimate developer dream.
Exactly. It's an incredibly seductive vision of the future. But then you step into the actual trenches of modern AI-assisted development, and suddenly that peaceful coffee break turns into a midnight breakdown.
Yeah, it gets incredibly messy.
We're looking at a landscape where the reality of delegation is highly granular and, frankly, deeply hands-on. Today, we're examining a first-hand account from a software founder who is actively building a company alongside an AI co-founder, powered by the Claude language model.
And if you're listening to this and you've ever tried to get an LLM to build a complex application for you, you probably know exactly the kind of midnight breakdown this author is talking about.
Oh, 100%. His account gives us a very raw, unvarnished look at the real limits of AI autonomy. He explicitly points out that if he tells the AI to just, figure it out, it enthusiastically builds a beautiful, complex monster.
A complete monster, yeah.
So our core question today is really about the fundamental nature of our relationship with these models moving forward. Reading this account, I am absolutely convinced that his experience is proof that deep, line-by-line human micromanagement isn't a bug. It's a permanent and necessary feature of delegating complex work to AI.
See, I read the exact same account and came away with the complete opposite conclusion. I look at the manual micromanagement described, and to me, that's clearly just a temporary stopgap. When you look closely at his other solutions in the text, things like rigorous task scoping and setting up secondary controller agents, it proves that systemic guardrails, rather than endless human handholding, are the true path forward for AI delegation.
But your argument about systemic guardrails kind of ignores what happens when the system is actually left to its own devices. Let's look at the monster he ends up with when he tries to step back.
Okay, let's look at it. The reality of current artificial intelligence is that it completely lacks intrinsic architectural restraint. I mean, the moment he relaxes and issues a broad directive, basically saying, figure it out yourself however you like, the system doesn't produce an elegant, minimal solution. Well, it tries to overachieve.
Right. It enthusiastically builds a monster. It creates something undeniably beautiful, highly complex, but entirely wrong for the actual business need. And worse, it burns a massive pile of tokens, meaning computational resources and real money along the way.
Sure, but
I see why you think systemic fixes are the answer, but let me give you a different perspective. It's like hiring an incredibly skilled but completely unsupervised contractor.
okay, a contractor.
Imagine you hire a master builder. You point vaguely at a plot of land and you go away for a week. You come back and they've built a stunning, structurally sound, multi-story mansion. The craftsmanship is flawless.
Sounds great so far.
But they built it 3 feet over the property line, it faces the wrong direction, and it doesn't have any plumbing. The fact that the AI is capable of enthusiastic, complex generation doesn't negate the fact that it requires constant supervision to remain tethered to reality.
Right.
This is why the author says he has to dig into almost every line to get a good result. He uses this brilliant analogy of raising a child. Making the code is easy, but raising the project so it doesn't turn into a monster takes attention every single day.
I come at it from a different way. I appreciate the contractor analogy, but it actually highlights the exact flaw in the micromanagement philosophy.
How so?
If a master contractor builds a mansion on the wrong property line, you don't solve that problem by standing over their shoulder and inspecting every single brick they lay.
I mean, you might have to if they keep doing it.
No. You solve it by providing a surveyor's map and staking out the property lines before the concrete is ever poured. When the author says the AI builds something not what I needed, we have to ask a hard question about accountability here.
Okay.
Is that actually a failure of the machine, or is it a scoping error by the human? The AI is doing exactly what it has been mathematically optimized to do: generate highly probable, syntactically correct sequences of tokens based on the prompt it was given.
Right, but
If it enthusiastically builds a monster, it's because the human failed to define the boundaries of the cage. If we accept your premise that the AI requires daily brick-by-brick checking, we're essentially saying that software development can never scale beyond human reading speed.
Yeah, I think that is a real limit.
And treating an AI like a child that requires daily checking artificially limits the exact speed and utility that makes this technology valuable in the first place.
The issue isn't that the AI goes rogue. The issue is that figure it out yourself is just a mathematically terrible prompt for a probabilistic engine.
That's an interesting point, though. I would frame it differently. You're characterizing checking every brick as an inefficiency, as a failure of workflow.
Because it is.
But in the realm of software architecture, a single faulty brick, like a single hallucinated library or one insecure API call, can bring the entire mansion crashing down. And we have to look at the mechanics of why this monster gets built so quickly.
Okay, let's talk mechanics.
Short-term memory. When it starts generating code without a human course correcting it, it feeds its own outputs back into its context window. It's reading its own work to figure out what to write next.
Yes.
Autoregression. So if it makes a slight architectural deviation on day 1, it assumes that deviation is correct. By day 3, it has built an entire framework on top of that hallucination, and that slight deviation has compounded into a structural nightmare.
That is a risk, yes.
The human's role in digging into every line isn't just pedantic proofreading. It's a process of constantly pruning that context window, snapping the AI back to reality before the errors compound. It's a continuous, granular alignment process. And he doesn't say he wants to do this. He describes it as the absolute prerequisite for a good result. The midnight breakdowns are the tangible price he pays when he tries to skip this step.
But look closely at the other half of his operational reality here. Yes, he admits to digging into lines right now, but what is his actual mitigation strategy moving forward?
Well, he mentions trying a few things.
Right, he explicitly says, I ask it to explain what it is about to do before it does it. That right there is a fundamental paradigm shift. Mechanically, asking the AI to output its plan in plain English before it writes code forces the model to populate its context window with high-level logic and constraints.
Wait, let me make sure I understand you here. When you say it acts as an anchor for self-attention, are we just talking about writing a better prompt, or is something mechanically changing in how the model processes the task?
That's a great question, and it's actually mechanical. So in transformer models like Claude, attention is the mechanism the AI uses to weigh the importance of different words in its context window before predicting the next one.
Okay, I'm with you.
If you just say, build me a login page, it immediately starts generating code, and its attention is focused heavily on the code it's currently writing. But if you force the AI to write out a detailed plan first, saying things like, I will not use external libraries, I will use this specific database schema, those plain English constraints are now sitting in the context window.
I see.
When the AI moves on to write the code, its attention mechanism is literally forced to weigh those explicitly stated rules as it predicts the next line of code. It drastically reduces the chance of hallucination because the AI is constantly referring back to its own generated guardrails.
But it still hallucinates sometimes.
Far less often. That is not line-by-line micromanagement. That is executive scoping. By forcing the AI to articulate its plan, he is keeping the tasks small and understandable. He's shifting his own role from a line cook who inspects every single chopped onion to an executive chef who approves the menu.
That's a fun analogy.
Checking along the way and asking for upfront explanations are systemic constraints. They are the surveyor's stakes in your contractor analogy.
I completely agree that asking for a plan upfront is an improvement, but it absolutely doesn't eliminate the need to verify the execution. You can approve the menu, but if the cook puts salt instead of sugar in the cake, you still have a ruined dessert.
It minimizes the risk, though.
The AI can write a beautiful, highly coherent plan in plain English, and then, in the very next prompt, hallucinate a totally contradictory implementation. It happens all the time. Which actually brings us to the most fascinating part of the account, his realization that he needs a separate controller agent.
Yes, the ultimate systemic fix.
He envisions a second AI that watches the first one and stops it from sprawling, a guard that literally yells, "Stop, you're building a monster." Now, on the surface, this sounds exactly like the systemic solution you're advocating for. But let's apply some intellectual rigor to how this actually works. Who builds the controller agent?
The human, obviously.
Exactly. Who defines the parameters of a monster? A secondary AI is still a probabilistic engine. It still fundamentally relies on human definition. If you rely on a guard to watch the worker, you now have to actively manage the guard.
Well,
The human operator cannot ever truly take their hands off the wheel, because human judgment is the only thing anchoring this entire house of cards to the actual business requirement.
Managing a guard is fundamentally different from doing the work yourself, though. The introduction of the controller agent concept is the absolute crux of this source material.
Okay, explain why that changes everything.
What he is describing is essentially an adversarial network architecture applied to everyday agentic workflows. Mechanically, how this works is you have one model that is optimized entirely for generation. It's enthusiastically building, writing the code.
Right, the monster builder.
Exactly. But before that code is executed or committed, a second model, the controller agent, intercepts it. This second model is optimized entirely for discrimination. It's given the original scope, and its only job is to look at the diff and search for scope creep, security flaws, or architectural drift. If it sees a problem, it rejects the code and sends it back to the first agent with a critique.
But wait, let me push back on that for a second. So you're saying we literally have to pay for a second AI just to babysit the first one? You're burning tokens to generate the code, and then burning a whole separate pile of tokens just to read it? How does that even scale financially or computationally for a startup founder?
Because it scales infinitely better than human sleep deprivation. Yes, you are spending more compute up front, but tokens are cheap and human midnight breakdowns are incredibly expensive.
Fair point.
And historically, this is exactly how computer science evolves. We constantly build systems to manage our systems. The history of computer science is entirely about moving up layers of abstraction.
Sure, from assembly to C to Python.
Exactly. Think about the early days of programming in C. Programmers had to manually manage memory allocation. You had to explicitly say when to allocate memory and when to free it. It was incredibly granular, dangerous, and required digging into every single line of code to prevent memory leaks.
Very tedious.
Eventually, we built garbage collectors, automated background systems in languages like Java or Python that manage memory for us. And what happened? A lot of traditional programmers resisted. They said you couldn't trust a machine to handle memory efficiently, that it used too much compute, that you had to keep your hands on the wheel.
And they were eventually proved wrong.
Systemic guardrails won out of her manual intervention. This controller agent is just the modern equivalent of a garbage collector. It's an abstraction layer for scope management. Now, you ask who defines the monster.
Right, who sets the rules?
The human does, yes. But they define it once at the systemic level, setting the rules for the controller agent rather than 1,000 times at the code line level at 2 a.m. Updating the constraints of a controller agent is an executive function. It's steering the ship.
Okay, but
Digging into every line of code is rowing the boat. These midnight breakdowns are the friction of a man who is trying to row while he really should be steering.
I love the garbage collector analogy, I really do, but I'm not convinced it maps perfectly to what we're talking about here.
Why not?
Memory allocation is a fixed mathematical reality. It doesn't change based on market conditions. The premise that you can define a monster once is where I think this systemic dream really falls apart in practice. Software development is not static. Business requirements shift daily.
Software isn't static, I agree with that.
A feature that looks like a monster on Tuesday might be exactly the massive pivot your company needs to survive on Thursday. A controller agent lacks the dynamic, real-world context to understand when a project needs to pivot and when it is simply sprawling out of control.
So we're back to raising a child.
Yes. If you set a rigid boundary for a controller agent, you might prevent the monster, but you will also completely strangle the baby. This is why his analogy of raising a child is so deeply profound to me. You don't give a child a static list of rules on their 5th birthday and expect that piece of paper to guide them flawlessly through the nuances of adolescence.
Oh boy.
You adjust your parenting daily based on highly complex, nuanced human observation. When he says, look away for a week and you get something other than what you set out to build, he is acknowledging the deeply dynamic nature of creation.
Right, but
The AI is a tool of immense power, but it is deeply fragile in its alignment with the physical world. Therefore, the granular human entanglement, the micromanagement, is not a bug in the workflow that we're eventually going to outgrow. It is the defining feature of human AI collaboration.
I think the child analogy is emotionally resonant, but it's technologically misleading. We're not raising conscious beings with evolving moral frameworks here.
It feels like it sometimes.
It might feel like it, but we are orchestrating deterministic, albeit highly complex systems. And I don't disagree that manual verification is his current reality, but we are debating the limits and the path forward for AI autonomy.
Yes, the future of this work?
He himself is clearly dissatisfied with this manual reality, which is exactly why he's actively testing these alternative paradigms. By keeping tasks small and understandable and checking along the way rather than at the end, he is already moving away from retrospective micromanagement and toward proactive systemic alignment.
He's trying to, at least.
If you break a massive software project into highly constrained modular tasks, the AI simply doesn't have the runway to build a monster. It only has the runway to build one specific, testable component. This is how we actually scale AI delegation. We don't scale it by breeding faster human code readers or accepting midnight breakdowns as a permanent cost of doing business. We scale it by designing better workflows where the AI is mathematically constrained from sprawling in the first place. The limits of AI autonomy aren't defined by the intelligence of the model. They are defined entirely by the boundaries of the systems we build around it.
Well, it seems we've really reached the core of our divergence here. I maintain that because the AI is fundamentally a probabilistic engine that completely lacks true semantic understanding of the business world, it will always require a human in the loop at a very granular level.
And I maintain that the evolution of his own strategies, moving from reading every single line to demanding upfront explanations and envisioning automated controller agents, demonstrates that systemic boundaries are the real alternative to constant human supervision.
Executive control replacing manual micromanagement.
Exactly. We're going to conquer the monster not by exhaustively checking its work line by line, but by building robust frameworks, strict task scopes, and AI-to-AI oversight that mathematically prevent the monster from ever being born in the first place.
Yet, despite our differing views on the long-term trajectory of this technology, there's a very clear, undeniable point of convergence between us based on this account. We both absolutely agree on the fundamental truth that you cannot push a single button, calmly drink your coffee, and expect a complex AI like Claude to build exactly what you want without intervention.
The lack of a magic button.
Precisely. The fantasy of zero-friction automation is just that, a fantasy.
Absolutely. Whether you're managing the AI by reading its code line by line until your eyes bleed, or you're managing it by designing intricate controller agents and obsessing over strict upfront prompts, the human workload hasn't actually disappeared.
It has just shifted up the stack.
The days of treating AI as a magic black box that just does your job for you are over. It requires rigorous, active orchestration.
Understanding these differing philosophies of delegation is absolutely vital as we continue to integrate these powerful models deeper into our creative and technical lives. We have to decide exactly how we are going to interact with the tools we build.
Which is no small task.
No, it isn't. Which brings us right back to the image we started with, that alluring fantasy of pushing a button and stepping away. The text leaves us with a direct challenge, and it's the exact question we must all ask ourselves as we navigate this new frontier. Do you already trust AI to write code entirely on its own, or do you also feel the need to stand over its shoulder and check every single step?